Hello, everyone, and welcome to MATHurdays. My name is Teresa Wells. I'm an assistant professor out of George Mason University, and I'm in the mathematics education program. And I've been teaching online now for a decade. Specifically, in the last 6 years, I've kind of changed my research interests into how do we make online learning more collaborative, interactive, and give students voice. I've worked with a variety of ages, as young as kindergarten through elementary, middle, secondary, and as teacher learners also. So I hope to be able to share some of my experiences with you all today as we explore some math together. Um, you're going to need two windows open for today. You're going to need Blackboard Collaborate, and you are also going to need Google Slides. This is the link for Google Slides, and I'm going to take down my projection. So if the only way you were able to see the slides a minute ago just went away, then you're going to need to click on this link here. And I'm going to continue to kind of spam your chat box with that link as new people are arriving. Today we're going to take a look at a math routine called slope reveal graphs, and then we're going to jump into a rich task all about a ski slope problem. Heading down onto slide 2, I mentioned that I work at George Mason University. This is an advertisement for our math specialist program. It is for K-8 math specialists, people who want to be math leaders, and it's 100% online, and this is where a lot of my research has come out of. On slide 3 are where you're probably going to want to bookmark. You'll notice that I have a link for my templates. All my templates are available to educators to use. And also, if you want a recording of this session, other sessions, and blank, fresh, clean slide decks, they're all available there. And then come on down to slide 4 for our norms for success. Make sure you put away all distractions. You are going to be highly engaged in this session, and the other people you're going to work with are going to need your attention also. We are recording, so reduce your background noise. If you have questions about the tech, about the math, about the pedagogy, anything, questions are fabulous. There is a space for them on the very last slide of the presentation. So if you have questions throughout, make sure they get there. I leave it the last slide so it's predictable where it is, and also so that I can remember to get to all of those. When you're in small groups, make sure you turn on your mics. Your words matter, so make sure you're using positive asset language when describing kids. Mistakes happen, and when they do, we'll just press Control Z. So if you accidentally delete something, you accidentally move something, just Control Z it and it goes back to the way it was. If you're on a Mac, it's Command Z. Make sure that you are not driving while participating. And if this isn't your first session, please update your profile picture as you get around to it. It really helps us to build community together and to see people from different angles, different things that are happening in their lives, their loved ones, and their pets. Alrighty, let's get you interacting. On slides 5, 6, 7, and 8, you can pick a slide. You are going to add a text box and tell us what you're celebrating. What successes are going on in your life? The text box is up on your toolbar. It looks like a T with a little box around it. And I'll ask a couple people to elaborate on them. It looks like there is a fairly large Hamilton club on slide 6. It looks like it's growing too. Raha, how is it?
Hi, Teresa. How are you?
I am good this morning.
So, Lara talks about Hamilton all the time because she is a theater and a movie buff. And I didn't have a chance to watch it because A, it's expensive, two, it's not the culture that I'm used to. So when it came out, I give it a shot, and now I'm obsessed. Like I can't stop rewatching it or looking at interview. And then I told Lara I'm going to save up to watch it live. But then I found out the original cast doesn't play it anymore. So I'm like, I'm not going to watch it. So I'm just like all over the place.
Oh, wow. Yeah, I can see some other people posting there. So there's a little place for you to build a fan club. Um, let's see, Monica, how did your classes go?
It really went well. I love one of the things they did was they were doing reading and they had to make words, and it was so cool to see them take the tiles and move them up. And I taught them about Control Z, and it really went well. They were able to make words, and I could see them doing it right on the slide. So um, that was really exciting for me.
That's wonderful. Yeah, when we can actually see our students interacting from a distance, it really does kind of connect us in the way that we would have seen that same thing almost by looking over their shoulder or being partner to partner with them. So that's wonderful that you were able to see that. Let's see, who is doing the cardboard box creations? Who's that?
Hi, my name is Tanya Parker, and I teach second grade. And so my son has autism, and my daughter is going to high school, and we have 8 pets. So they've created some guinea pig mazes, and today for the 3 guinea pigs, she created little houses for them to go in to get their food for each day. It's just been really fun being an engineer and designing them.
Oh, cool. I put a word here. Make Do is a company that makes these little screws that are really easy to handle, and their purpose is to put cardboard together. They're dull, they don't hurt young kids, but they're super cool. We've got a little set of them, and we reuse them and build all kinds of cardboard stuff all the time. So check
Hmm,
those out.
thank you.
Yeah. Lily, how's the espresso machine station? I think I need you in my life.
So like anything else, and you're so limited to as to what you can do to entertain yourself, being stuck at home. So I felt I am so passionate about espresso, but I saved all the everything to buy a least expensive espresso machine. So now I just wanted to make it a special corner so that it's exciting to come down to the kitchen in the morning just to make a cappuccino. So it's been great.
Oh, that sounds lovely. I think I need to do that so I can get excited to
Highly recommended.
to wake up and make it.
Yeah.
Wonderful. Um, and folks, I'd like us to just take a second and look at slide 6. This is what starts to happen in your classroom communities when you do successes and celebrations. I know several of you all have been coming to MATHurdays fairly regularly, so this is not your first time, and you're probably starting to recognize some names and people. And what happens is when one person writes one thing on a slide, other people start to comment on it. Um, Other people start to get interested in it. They start to leave their Twitter handle, or in my students' cases, their Minecraft gamer tag, so that other people can network outside of the class as well. Um, so this is the community. This is the part that you don't always get in online learning, but you do get when you make your community slides purposeful, and you give students the chance to write directly on them. So kudos. All right, folks, let's jump into our math routine. I've got the bookmark on slide 9, but we'll begin on slide 10. I did not create this routine. It came from the slowrevealgraphs.com, and the link for those are below each graph. So if you want to know more, they're there. Um, but we will just kind of have a open discussion. You're welcome to turn on your microphone, raise your hand, and or if you prefer, write in the chat box. But what do you notice about this graph?
Hello.
Hi.
Hi. I notice a steady incline and then a very high uptick. So there's something going on that has made it accelerate higher.
Ooh, I like that term, accelerate. Let's see. It's linear, but the slope changes. There's an uptick, 3 points, upward trend. All right, let's look down at slide 11. One thing I do if I want to keep something hidden is I just put a white text box on top of it, which is what this is. It says intentionally left blank, and then I delete that off, and my image is behind it. All right, we have some new information. Feel free to turn on your mic, tell us what you see, or type it in the chat. Oh, Gail, would you tell us a little bit about what you noticed?
I noticed that the first went from 2011 to 2013, which is only 2 years, and then it jumped 4 years for the same distance horizontally.
Interesting.
And it kind of like 2015's missing in there if you wanted to have the same distance between data on the horizontal.
Oh, very cool. All right, let's come on down to slide 12. We have some more information. Feel free to use your mic or chat box. What do you notice? Yuko, can you tell us a little bit about why it's important to say equal here?
Oh, you mean the interval?
Yes, yeah.
Yeah, it's I tell my kids that y-axis has to have if it's a numerical data has to have an equal interval unless it's exponential.
Right here. So, and Donna also noticed that it's not skewed. It's not, you know, they're not trying to mislead you here. Let's check out slide 13 and keep them coming. What do you notice?
Hello?
Hi, go ahead.
Hey, it's me again. I wonder, now that it says the media usage, average mobile media usage, I wonder if the 0 through 50 is millions, thousands, tens, minutes, hours. Like, I just wonder what it is. That's my wonder.
Very cool. All right, let's check out 14. So what might be some good titles for blank per day? You'll notice the little blank was taken out. What do you think would be some things you would expect to see there? I see hours, minutes. So we think some kind of a time. Who can defend why you're thinking of hours and minutes and why not number of devices or number of shows or some other quantity? Why hours and minutes? Yeah, go ahead.
Thinking about the title where it says average mobile media usage, when you're using your phone, it usually tracks how many minutes or hours you're on your phone for media usage. So I'm thinking it might be another time label.
It looks like Laurel agrees with you and says it's the most logical and consistent measure. How about slide 15? I know some of you are going to be kind of excited to see the minutes on there, as that was what you were mentioning. And that's our final graph. And so we can get into a lot more discussion about this graph. The author of this slow reveal graph also posted some other interesting facts about media. And we can use this to have more discussions about graphs. But the questions you just had, the kind of noticings and wonderings, what that kind of is more of motivating kids to actually care about, why do I have to label my axis? Have any of you all been in that situation where you're like, gosh, why are you just making me do all this stuff? It's not really that important. People get it. Were you all motivated with this? Oh, Laura, can you tell us a little bit about what you just posted there, what you would expect in 2020?
I guess I would, the first thing I think about is, oh my gosh, if that's 48 minutes seems really low, but that's 2017. So I'm wondering like what the graph would look like in my mind. I just keep like the slope would increase, but especially with schools being closed and us asking kids to do online learning, that number would jump significantly, I would think.
Feel free to put a data point. What do you think it would be? I've added that slide down on the slide below with a lovely horizontal bar. You can just grab a little circle and give us a data point. Where do you think it would be for 2020? And I'm just going to leave this up here. I'm not really going to do much with it, so you all can explore that more if you'd like. And then the other thing I wanted to mention before we get into our task today, I always try and give you guys a connection to literacy so that you can have that also. Slide 21 is my bookmark and 22 is the story. And in this story, they go on a picnic, and one ant carries away one little thing, two ants carry away two little things. It goes all the way up to 128 ants grabbed some cheese and trailed off. And so the more ants they have, the bigger the amount of food they're able to take from this picnic basket. So I hope you enjoy that. You can watch that at any time, and then we will jump right into our task for today. So if you join me down on slide 24, we have the reason for why we do rich tasks. And this comes out of the National Council of Teachers of Mathematics. And the principles to action, these are the 8 math teaching practices. You should see very clearly here today that I'll hold the discussion on a specific goal. You're going to incorporate problem solving, representations, conceptual understanding, and hopefully even productive struggle. I will use evidence of your thinking while you problem solve and purposeful questions in the math discourse. So I hope to showcase everything here. Join me on slide 25 for our problem-solving oath. And if you agreed and you pledged to do this today, go ahead and type your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Look at all these great problem solvers. All right, our task is on slide 26. And since my daughter was watching School of Rock while I was making this, try to go with a little song title. It's a long way to the top if you want to ski and board. Slope Mania would like to design a ski lift for an intermediate slope. Now they already have 2 ski lifts and want a new lift to maintain the same distance between the chairs. The Diamond ski lift is 1.5 miles long, and the chairs are about 140 feet apart. Their beginner slope is 1,500 feet long and has 20 chairs on the lift. Make recommendations for the intermediate slope. There are 5 starter manipulatives on the slide below, but you're not limited to those. You can use any manipulatives you want. And I'm going to start breakout rooms. Just a minute, let me get them. All right, our breakout rooms will start in 3, 2, 1, now. Hi, Group 1. Go ahead and turn on your microphones and introduce yourselves, and you guys can start on slide 28.
Hi, I'm Kyle. Hello. Anyone else here? Hello?
Bev and Nisha, are you here? All right, Kyle, I'm going to add your group to another smaller group. I don't know if they're having microphone issues or if they're present. That way you have a group to interact with.
Great, thank you.
Yeah, no problem.
Love this problem. I'm a snowboarder.
Oh, really?
Yeah. Well, back in the day anyways.
Hold on. What I'm going to do is I'm going to copy the problem and drop it onto the slide so that I don't have to keep going back and forth. It's always hard for me to like toggle back and forth between the slides.
Yeah, me too. Okay, back to 36.
I don't think we need to. We can just put in text box on the sides.
Okay. Well, I did a 36 slide, so.
So it looks like one of the things we have to do is change 1.5 miles.
Into feet, yeah. Miles into feet. Hey Siri, how many feet is in 1.5 miles?
1.5 miles is 7,920 feet.
You got that, girls? Okay. 1.5 miles.
Mm-hmm. I'm just going to start a box here to take notes.
Thank you. So then we have the 20 chairs. So that's different from any distance calculation. So am I understanding correctly? So that even for the kiddie one, that the chairs are still 140 feet apart, or am I misunderstanding something?
I think that's right. They're
Okay.
still 140 feet.
Yeah, I think it's consistent. Like it's like standard. They have to be that far apart.
Yeah. Okay. And then the beginner slope. So we have to figure out what would be halfway between those two.
Okay.
It's halfway between 7,920 and
Harder. So what was your name?
Brenda.
So and what did you say again?
I just said you wanted to have a reasonable increase of difficulty between the easy slope, but you didn't want it so hard that it made it feel like it was hard. It needed to be that in-between point. Does that make sense? I mean, the increment was like a reasonable expectation of difficulty, not something that would be too hard. But
So do you want to use a graph on Desmos?
I think that so I can do the little bit of, I can just do the little bit of I can kind of do the explanation like up here at the top, and then if somebody wants to, because I don't want to do everything, I don't want to take over, so I can do the little bit of explanation if someone wants to add a little graph to that screen.
Figure out the recognition, I'm not sure, or how you compare them to each. Like, putting the different things in the boxes, like what the information we have, and then figuring out what's missing. Like in Diamond, we have how long it is, and the chairs, how far apart they are. But in the other one, you're right, they had it in feet instead of miles, and then they just say they have 20 chairs. So we need to figure out how many chairs, I believe, in the Diamond ski lift. Maybe, I don't even know if that's important or not, but
That sounds good.
and then the other, and then what we're missing in the other one is how far apart the chairs are again.
Looking at I got used to the interactive number line, but I got it out. I'm trying to figure out this interactive number line, trying to make my number line fit at 1.5 miles, but there's needing to be.
Hi, group. I love this number line tool. Is that a different manipulative?
no, Teresa, that was from the Math Learning Center number line. If you do it with no information, you can just put the text boxes and label them.
Oh,
so that's what I did.
That is so cool. I love learning new things. Thank you for sharing that with me.
You're welcome. I just love number lines so much.
Well, and I think that that model really kind of gives us like a bit of a heads up of like, okay, if this is where it is, where do we want kind of future ones? Where do we want past ones? And it really does line up two pieces of information really well.
It really helps me to process two things at once when I have the double number line. So that's why I always like that strategy.
so that's about 756 chairs on the, yeah. So do we want to do like 6,000 feet or something less or something more for the intermediate?
For the distance, do you mean? Is that what you're
Yeah, for the feet long, or like 5,000.
Yeah.
Maybe.
Would we want to make it friendly and just do like 1 mile, which would be that 5280? I don't know.
Oh yeah.
For an intermediate slope.
Right, okay, yeah.
And so I'm not even looking at the, the preciseness of the math yet. I'm looking at how can I use what I have to look at a general estimation of where I could be.
Okay, and I changed it's 7,900 feet for 1.5 miles, not 7,290. I changed it.
Yeah, 7.9.
Yeah.
Okay.
Hi, group. I am so curious about your assumption and how that challenged you to think about the problem.
Okay, we can start. I was thinking if you were to do, if it's 1,500 feet going up the slope to like the top of the mountain, is it also 1,500 going down the slope? Because I did the math, is that if each chair is 140 feet apart, there's 20 chairs on the little one, beginner slope one, it wouldn't fit on this to 1,500.
Interesting. So you're thinking that that little beginner isn't really 1,500 feet. You're thinking it as like 1,500 feet down and then back up?
Yeah.
Very clever. I think you're the only group that has kind of found that or discovered that. And part of that was in the context of the problem. And so sometimes our context can be tricky for students to understand if they've never been on a ski slope. But keep going with that. You guys are doing a fantastic job.
Yeah, I was thinking about that for a minute, and so if you're looking at that 1,500 and you divided it by the 20 chairs, if it was just the 1,500, that would be 75. But if it's actually, you can spread them more because you also have the other side going down. If that's what you're saying, then that number is closer. I mean, the total is double that. Like 150, which is similar to the 140 of the other slope.
Very cool. Keep going with that assumption, guys, and I'm going to have you all chat about that when we come all back together.
So are we supposed to be plotting something on this slide, like a little demonstration? So maybe we could just put 56 or 57 because it's 0.57.
Okay.
And then do we want the chair intervals to be equidistant of 140 and 75 or not?
That's the one I think that's a scaling or a proportion. So 1,500 is to 75 as 4710 is
minus 75 divided by 2. Maybe 68.
So 1,500
no.
x equals
so 175
times 410.
40 feet minus 75 feet. 65 feet.
Hi there, group. I heard you say that you're using proportions and then scaling, and I think that that is sometimes a concept that's brushed over too quickly in middle school. Like we either do scaling or we do proportions, but you guys found a reason to kind of need to know both of them in the same problem. Would you find a way of visually posting that on your slide? And it's perfectly okay if you just did that on paper pencil and you want to take a picture of your work and post it. But I'd love to talk about how it's important to know both of those in this context.
We'll try.
Wonderful, thank you.
All right, so how can we visually show that? Like, how can we represent that visually, like with pictures or like text boxes? 65 spaces. If we do 100 and we say that we wanted our length to be 4,500 feet, that'll be 45 chairs, right? Yeah.
Or we could do.
I'm gonna be honest. I've never gone skiing, so I have no idea.
Yeah, I have no idea either. But maybe, and just playing with numbers because it's not going to be exactly in the middle. But maybe if we can make the distance like 110 feet.
That's what I was thinking. Yeah.
And the length make it 4,400. Then
we'll have 44 chairs. That's kind of in between.
Yeah, and then you would have 40, right?
Oh yes, 40. Yes, you're right.
So it's not exactly in between, but it just looks like a nice number.
Yeah, but we're making recommendations. So
the number of feet for our slope.
Figure that out, you could figure out the slope of each line. So how you just represented that, the medium one looks like it's less.
Right.
So if you're using the Desmos calculator,
yeah.
If we were at 0.0, we're going to assume, I don't know if you're assuming it's linear, you would have gone 0 miles, right? And if you were on chair 1 and you went over a period of time, where would you be at the end? So we could maybe think of 2 points, and we could create a graph.
So you're kind of suggesting we should also check out the slope.
Yes.
Okay.
Because on a ski slope, the diamond is generally steeper.
Correct.
And so by the time you got to the top, so I'm just going to use 8,000 because it's a whole number.
Exactly, yeah.
It's easier for me to think about. So that would be, I don't know what the elevation would be, but it would be the highest point, right? And then intermediate might not go up as high as
Welcome back, everyone.
Bye.
Hello and welcome back. We're all back together in the main room. Can you believe you've already been working on that for 20 minutes?
Wow.
And the second half of the time here we'll use for our discussion. And wow, there were some really, really incredible ways of looking at this problem. So what I've done is I've selected a couple of representations based on my mathematical objectives. And I've got kind of two objectives here. I want to highlight something that is really important in second grade math, and then scoot over into something that's really important in seventh grade math. And of course, I'm going to hit many grades in between there. So if we can come on down to slide 40. Oh, just kidding, 39. All right, slide 39, we have some different representations here. And what we're going to do when we look at these representations is really focus on where could the intermediate be? Where is its location on this? And we are going to start off with the turquoise, pink, and purple one. So if you did this one, can you tell us what your choices could have been for the pink? Where could this one be, and how do you know?
I think that was our group 7, I want to say.
Yeah, so why did you pick the pink to go here, and how did you know that?
Well, I think we were thinking of something that was halfway in between, but then we were thinking about like some of our group members had some real experience on a ski slope saying it was not always exactly halfway, that the intermediate slope was sometimes closer to a diamond than it was to a beginner. So just using some real experience to guide our thinking there.
Neat. So you've used prior knowledge and this sense of halfway. I'd like to ask the same question, and I believe it was the same group who did the green bars. Tell us why you picked your intermediate, your in-between one there, and we'll call that the green arrow.
That one I did not make, and I couldn't figure out who did. So if someone knows who made it and want to explain that.
Yeah, I was in group 7 too, and I didn't make that one either. We were trying to figure that out where it came from.
So who can interpret this graph, this model, I should say? What does it mean, and why do you think they put the in-between where they did? Glenda, go ahead.
Well, I was just looking at that little scale bar that they have at the top. So that's what I was using as a guide.
Ooh, so that little scale bar, if that little scale bar is important to us, what might we be able to say about this bar? Could we give this bar here some numbers?
Mm-hmm.
So if you think you know what that bar could be in terms of numbers, go ahead and write that in. I'm just curious what we're interpreting from this.
150 feet.
And as people are typing those numbers in, I'd like to draw our attention to the electric blue arrow. And this group has their medium, excuse me, and I'd like you guys to, whoever did this, turn on your mic, tell us kind of what this model represents and how you decided to put this medium one right there.
Hi, Teresa. It's Laura. Group 9, we were kind of talking about how we would think that the intermediate ski lift would be like the halfway length between beginner and diamond. So since I teach 4th grade, I kind of always bring everything back to a number line and helping like from a fourth grade viewpoint, like how you would calculate what the halfway distance would be, and figuring out like the difference between 7,920 and 1,500, and then calculating what that exact halfway point would be in feet.
So you guys found an exact halfway. So here's one of the interesting things about these different models. I mentioned I was going to start in second grade. When we teach subtraction to second graders, so frequently we will take the bigger amount, subtract it from the smaller amount. And we'll use word problems that say something like, I had this many coins and I gave away some other coins. So we kind of taking it apart from the main one. But here, this problem is really forcing us to simply look at the in-between. So where that yellow can go as possibilities, or where this pink could go in terms of just possibilities. Is there anyone who teaches this idea in second grade where you're really looking at the in-between, and how does this model help you to see that?
Yeah, this kind of comes up when we're talking about fractions.
How do you see it with fractions?
Because fractions are in between numbers many times.
Oh, very cool.
Hello?
Yes.
I was thinking also too, if you do like a count up method, if you like counted up in increments even of like 500, like thinking of second grade, you could see how many 500s get you between, 1,500 and, 8,000, or, so something like that, like a counting up method.
Lovely. And so what we're doing here is we're looking at differences. And most of our assessment questions in second grade will come up with something like, Roger is 3 feet tall, his dad is 6 feet tall. How many feet taller is his dad? Or questions where you're really interested in that kind of in-between area. And they're by far the most challenging for our students to understand. And so I always like to try and give them problems where they're playing around with that range, that in-between area. To piggyback off of our graphs from earlier, what do you notice about the units in the graphs that are the representations that we've talked about so far? Raha, go ahead.
That's what I was noticing as I looked at the different models, is that some are represented in feet while the other ones is in mile. Where your yellow arrow is, it now makes sense why that might be an intermediate, because between 1900ths of a mile and 1.5 miles, 1 mile might be a good, like a roundabout number to be in between. Because I was thinking in feet because I converted everything to feet. But if I had done the other way, it might have been a different perspective.
So this one here, our medium at 4,710 feet is just under a mile. And while that might be the exact midpoint, maybe for advertisement reasons, they're not able to say like our slope is a whole mile long. So we've got some kind of different ways of looking at that. And then we've got this other representation. And can this group in the pink arrow tell us about what you were thinking in this representation? And as they do, everybody else in the chat box, tell us what you notice about the labels.
Hi, this is Sally. For our group, when I was thinking about this problem, there were a lot of numbers going on, and to help keep track of things like the number of chairs, the length of the whole slope, and then the distance in between chairs, I wanted a way to structure it for myself. And what you can't really tell in the number line is I actually started with the 20 chairs and the 1,500 feet. And then I used halving and then a little bit of doubling to go back and forth to get from the 20 to 10, and then cutting that in half again to 5 chairs and how long it would be. Just because my group is doing some awesome work with spreadsheets and conversions that I am not good at converting 1.5 miles to feet as quickly as they were. So that's why I wanted to work with some smaller numbers, and then we could use that to reason up for other options like option A and option B that are posted below.
Lovely. What units did Sally use in these representations? What do you notice? And so, Sally, here, I've seen that a couple of people have mentioned chairs and feet. So she's got 2 different units represented on this double number line. There was another group who used prior knowledge to think about this problem differently. And I'd love for group 8 to, can you tell us about the assumption that you made and how that changed the problem for you? If we can all head up to slide 37 for this. Slide 37. Tell us your assumption and how the numbers changed for you.
Okay, so this is Chelsea. From prior knowledge, we know that the ski lift goes up and down, and we were thinking that the 1500 is just going up, so you needed another 1500 to go down. Because I did the math, but you did like 140 feet times 20, you need 280 feet to go both ways. So 2,800 to go both ways. So that was our assumption that we figured out. But we just used the numbers that were given to figure out a problem.
So Chelsea, in your table over here, I think most people got this number. Again, we're on slide 37. I think most people got this number for the diamond, that they were 140 feet apart. How did you get that the beginner was 150 feet apart?
I'm not sure. You could ask one of my other group members.
Okay.
That was me, Amy, and I was thinking about that we had, if we were thinking of it, that it was 1,500 feet up and then also down, that at first I thought of it dividing it between just the 1,500 feet, but because I had extra space, I doubled it because it was also, I could spread the chairs out amongst the whole line.
Very cool. And that group was also talking about kind of some consistency, which made this number here, the 145, a little bit easier to think about. And Lily brings up some prior knowledge that maybe you need more distance between the chairs because the beginners may fall often. So the fun part about this problem is you can have groups work on it 2 different ways, considering that the lift goes up and down, or that you're only considering that vertical height. But either way they're looking at it, the math that's happening is still going to work out for the discussion. One other group, group 9, started talking about why you need to know proportions and scaling. Can we all head to slide 38? And would group 9 tell us, how did you think about proportions and scaling? On slide 38.
Well, we compared the number of feet. Okay, I didn't take a picture of it, but we did 7920 is to 140 as 4710 is to X. So we got the chair intervals. And then I also tried 1500 is to 20 as 4710 is to X. And it took me a few tries. So I'm still not positive my math is correct. And then I went to a spreadsheet. I copied this table and put it into a spreadsheet and created this graph.
Awesome. And we can actually see these numbers on the graph here as we look for like what's the in between. All right, folks, that is our time. I hope today that I showcased the importance of looking at that in-between distance in terms of subtraction, especially for our second grade teachers, and also getting into finding the midpoint, converting numbers, and also using proportions. If you all would come down to slide 43 or 44 and let us know what grade do you teach and what topic could be relevant in this problem. I hope also for you Algebra 1 teachers, you could see a variety of points that you could graph on a linear line that would represent each of those little ski chairs as it goes up the lift. But hopefully we can see this problem being used across multiple grade levels. I see some people were talking about beginning algebra, working with Desmos. That's a very powerful tool. It does involve a little bit of learning how to use it, but once kids can get a hold of that, they can really unpack their math. Unit rate, ratios, proportions, measurement, conversions, problem solving, multi-step problems. Well done, everyone. All right, just as a reminder, on slide 45, all my slides and templates are available for you all to use. I should have this one up within the next 24 hours. And if you have any questions, I am happy to answer them and just post them down in the discussion, the parking lot at the very last slide. Somebody's already asked for the picture of a concept map, so I'll go ahead and insert that here. Take a picture on my phone real quick. Thank you, Glenda. Alrighty, let's see if I can get that uploaded. All right, it's uploading right now, so once that is in there, I'll be able to post it in. Raha asked if the next math workshop is going to be about fractions. It will be. In August, I plan on doing another more variety. I've got a book deal right now I'm really excited about, and I have to have the draft in at the end of the month. And so I am writing and writing and writing and writing and not really spending too much time changing up these. So I'll get those out in August. Someone asked, do I use two screens when teaching? Since the pandemic started, I've got my little home office down here, and I do. But typically, I mean, for the last 10 years, I just had my laptop. I stagger windows, and I can give you a video on what that looks like so that you can try staggering windows also. But I typically didn't have two screens. And I don't usually optimize the space for two either. All right, here is the way that I stagger my windows. All right, Donna, let me see if I can get that up. There it is. And actually, Donna, I'm going to put it on the next slide, just so you can see it. It really wasn't super pretty. I mean, it's got a lot of like chicken scratch on it, but I'm kind of looking for important things about labels. And then in the end, I wanted to move from second grade, looking at the difference, to proportions and scaling. And so that was kind of what I was drawing up today.
Thank you.
Yeah.
Because I'm reading through the 5 practices book, and so I was just plugging it all in, and this really helps. Thank you.
Is manipulating manipulatives virtually considered concrete or representational? Ooh, Paula, I have an entire paper that I'm working on this, and I'll give you kind of my ideas here. If it is a picture that you are then posting on your slide, such as this one here. This was once concrete because people were moving it around, but once they took a picture of it, it became static and we can't move it anymore. And so I call that one a static concrete at that point. And then I also, if it is representational, I'll bring up, is it dynamic representational? Because there's 2 ways to kind of think of it. It's like a before and after. If you have instead, let's see, this one. So here's the other one that we did. If you took a look at this one here, it is representational, and we could look at it just simply as it is, but because I could manipulate this yellow one as we're talking, it really is a bit more like concrete. So I do try and use the idea of, is it dynamic? Can you keep moving it, or is it static and it's a picture in time? But still working on those ideas. The July 23rd session, I don't even know. I gotta look at my calendar here.
Teresa, that was me, Lily.
Yeah.
It was about the strategies for any subject area, but I wanted to know more about it to see if it's going to be applicable for my 3rd and 4th grade group.
Absolutely. So it's all about getting students to talk, to communicate, to share ideas, to steal different ideas, edit those ideas, to do a exit ticket kind of thing, and it goes across any content area. Sure. All right, I think I got to all of those questions. If you'd like to join us for other PDs, I've got lots of other PDs. Just check them out. And happy MATHurdays, everyone.
Thank you.
Thank you. Amazing as always.
Thanks. All right, folks, have a good one.